In example 1, we're going to be graphing a logarithmic equation. We're going to do this using technology, namely a graphing calculator. So if you do have a graphing calculator, please get that out. If you have it out already, you're ahead of the game. If not, you can pause the video and grab your calculator. To do this, we're going to make a table of values. So the top row here is going to be x, and then the row below is going to be f of x, or y values. And we're going to arbitrarily pick those x values. I'm going to pick a few for you, and we're going to see what happens when we type this in our calculator. So I'll choose -1 for x, 0, 1, 2, 3, and 4. To type this in your calculator, you're going to want to do one of two things. Every graphing calculator should have the ability to type this equation in, or this expression in, log of x divided by, and you do need to close a parenthesis there, log of 3. And we're simply just going to be substituting x values in for the x, which is right here. So you should be able to type that into your calculator using an actual value for x and get the corresponding y or f of x values. If you have the log base program in your calculator, that's under the math menu. If you hit that math button on the left-hand side of your TI-84, then cursor down and it might be 0 or A, I think. It'll say log base. If you do have it, you can use that. And if you hit log base, then you're going to get something that looks like this. And there'll be a little box right here, and then there's going to be a slightly larger box over here. So in your case, you could type the 3 in that little box, cursor over, and type whatever your x value is into the argument position, which is where the x is here. If we do this with -1, and you can take a minute to do that, but you're not going to get any value here. As a matter of fact, that x position cannot be, the argument position cannot be negative. It also can't be 0. So go ahead and try this on your calculator. Pause the video and type in log of -1 divided by log of 3, or you can use the log-based program, and it's going to wind up with something like a domain error or some kind of error. If we type in 1, though, we're actually going to get an answer for this one, or a value, and that value should be 0. So take a second or two, type that in your calculator once again. If you need to pause the video, go ahead and pause the video. That point, 1, 0, is actually right here on the graph. So we're actually going to graph that right now, and then we're going to fill in some more points as we go. So when x is 2, if we type log 2 divided by log 3 in our calculator, we're going to have an approximation here, and I'm going to approximate that as about 0.6. So when x is 2, our y value is about 0.6. So that point is right here on the graph. And we can keep going with this when we type in log, oops, that's kind of a slanted one there. When we type in, oh, come on, erase. We'll have to use the erase feature here. Stand by. There we go. Okay, and so when we type in 3, we actually get 1 as our output. Log of 3 divided by log of 3 is, well, 1. If we type log of 4 divided by log of 3, we get 1.3. So we can graph those points. 3, 1 is right here, and 4, 1.3 would be right here. Some other key points that you might be interested in plotting are when x is equal to 9. When x is equal to 9, if we type that into our calculator, our y value should actually be 2. So we can extend this table just a little bit here. I wanted to get to that part. And we can plot that actually here. So I'll plot 9, 2 on our curve. And you can also type this into your y1. So if you wanted to type y into y1, you go to your y equals button on your calculator. You can type in log of x divided by log of 3 and actually see the graph of this thing. When you see the graph of this thing, what it's going to look like is it's going to look like a line that kind of curves like this. I need to hit more of those points right there. And actually, this curve is going to continue to get closer and closer and closer to the y-axis as we continue in the downward direction. That's actually important. Some of the graphing calculators will not show that portion that we just drew that's to the left of 1. The vertical asymptote for this one then happens to be a vertical line passing through an x value of 0. There is no horizontal asymptote, even though it looks like this logarithmic function might level out. There's no horizontal asymptote, just a vertical asymptote for these logarithms. If you're comparing this to exponentials, exponentials have a horizontal asymptote, and a logarithm is just the inverse, so the x's and y's are switched. So instead of a horizontal asymptote, a logarithmic function will have a vertical asymptote. The domain are the possible values of x, and for this one, we're going to list that as 0 to infinity. If we take a look at the graph, only x values from 0, not including exactly 0, that's why we draw the parenthesis on the left-hand side, all the way to infinity are possible. The range is kind of like the domain for exponential functions. So the range is actually all real numbers. You can tell in the graph here that every single y value is possible. Some students think that over here on the right-hand side, that graph levels out, but it actually continues to grow. It just grows a little bit more slowly as we increase the x value, but it would continue to grow forever and ever. So we could reach a very, very high y value. The x-intercept, we can tell on the graph, is going to be 1, 0. So that's this point right here. We can also look at the table of values, and we can see that where the y value is 0, the x value is 1, and that's going to be your x-intercept. This graph never crosses the y-axis, so you can write none or no y-intercept right here. The graph does not intercept the y-axis at all. It just gets closer and closer to it. For the end behavior, as x approaches infinity, the values of y also approach infinity. I know it kind of looks like it levels out, but the function never actually does that, as we just discussed before. We have to make a little change for the left end behavior. If I'm a point on the graph and I have to go to the left, as I continue trying to go to the left, I keep getting closer to an x value of 0. So we actually can't approach negative infinity. For this particular equation, we have to approach 0. And what do the y values do? Well, the y values continue to go down forever and ever. That's supposed to be infinity symbol. Let me go ahead and try to draw a better one for you. There you go. And we're done.